Hey, what's up guys, welcome back to this video. In this video we're going to solve a coding interview question, integer to English words. This is a LeetCode problem. Convert a non-negative integer num to its English words representation. If you are given integer 1, 2, 3, you have to return 103. And we see that this is a number and the words representation of this integer is 103. When you convert integer to English words, in this problem we have to use the words we have in these 4 boxes. We have the word from 1 to 19, then we have the words for multiples of 10, 10, 20, 30, 40, 50, 60, 70, 80, 90, then we have 100, and then we have multiples of thousands, thousand, million, billion. So if you are given an integer, we have to convert that integer to English words using the words we have in this 4 box. We cannot use the words except this 4 box. Now how we can solve this problem? First, let's see some examples. Now let's see some examples. If we're given 1, 2, 3, we have to return 123. If we were given 1, 2, 3, 4, we have to return 1234. If we are given 1, 2, 3, 4, 5, we have to return 12,345. If we are given 1, 2, 3, 4, 5, 6, we have to return 123,456. If we are given 2, 4, 1, 3, 5, 7, we have to return 241,357. If we are given 1, 2, 3, 4, 5, 6, 7, we have to return 1,234,567. If we are given 1, 2, 3, 4, 5, 6, 7, 8, we have to return 12,345,678. If we are given 1, 2, 3, 4, 5, 6, 7, 8, 9, we have to return 123,456,789. And if we are given 5, 1, 2, 3, 4, 5, 6, 7, 8, 9, we have to return 5,123,456,789. Now how we can solve this problem? You might think this is a super difficult problem, but I don't think this is a super difficult problem. Now let's see how we can solve this problem. We have to solve this problem from the right to left. First, we have to find out the value of last 3 digits. Okay, we have to solve this problem 3 digits by 3 digits. For this integer we have 1 to 3. We can say this is our base. First, we have to find out the value of 3 digits. When you have 1 digit, 2 digits, and 3 digits. Okay, and that's our base. If we have 1, 2, 3, we have to find out 123. But how you can solve this problem when you have 3 digits? And we'll see how you can solve this problem for 3 digits. For this integer, we have 234. 234 is our base, we can say. So 234. So here we have 234. First 3 digits from the right is, we can say, base, and for the left of last 3 digits is for 1000, and again the left of 1000 3 digits is for million, and for the left of million digits we have to consider for billion digits. Don't worry about that. For last 3 digits we have to consider our base. Then for the next 3 is for 1000 on the left, then the next 3 is for million, then the next 3 or the rest is for billion. Don't worry about that, we'll see. Here first we have to find out 234. Then we have 1 for 1000. So we have added here 1000. Then for this integer, first for this 345, then 12. Here we have 2 digits, 12 for 12,000. 12,345. Then for this integer, first for this 3, this is, we can say, base 456. Then we have 123, and this is for 1000. This is the next 3. Okay, so 123,000. Then for this integer, first for this 357. Then we have 241. This is for 1000. This is the next 3 of our last 3 digits. So 241,000. Then for this integer, the last 3 digit is 567. So 567. Then the next of this last 3 is 234. This is for 1000. So 234,000. 234,000. Then the next 3 on the left, we have only 1 digit, so this 1 for million. First 3 digits on the right is for, we can say, for base. Then the next 3 from the right is for 1000. Then the next 3 is for million. Then the next 3 and the rest is for billion. So here we have 1 million. Then for this integer, first we have the last 3, 678. 678. Then the next 3 from the right is 345. So 345. This is for 1000. Then the next 3 from the right is 12. So this 12 for million. So 12 million. Then for this integer, the last 3 is, we can say, base 789. So here we have 789. Then the next 3 from the right is 456. This is for 1000. So 456,000. Then we have 1, 2, 3. The next 3 of 1000 is 1, 2, 3. So this 1, 2, 3 for million. So 123 million. Then for the last integer, the last 3 digit is 789. So in the last year we have 789. Then the next 3, this is for 1000, 456,000. 456,000. Then for the next 3 on the left is for million. So 123 million. 123 million. Then the next 3 from the right, and here we have just only 1 digit. If we have here 3 digits or more, and all will be evaluated for billion. Here we have only 1 digit, 5, so 5 billion. Here we have 5 billion. Hope you have understood how to solve this problem and how you can read an integer. Okay, hope you have understood in a very high level. Now let's see how you can find out the base condition when you have 1 digit, 2 digit and 3 digit. When you can solve the problem for 1 digit, 2 digit and 3 digit, then we can solve this problem pretty easily. Now let's see how we can solve this problem. Let's say we have this word, empty words, and we have this 4 box. We can use the value of these 4 boxes. For less than 20, 0 means empty string. 0 is your base case. 0 means empty string, 1 mean 1, 2 mean 2, 3 mean 3, 4 mean 4, and so on. Then for 10, 0 means empty string, 1 means 10, 2 means 20, 3 means 30, and so on. For 100, we have only 100. We'll use the 100 string directly in our code. Then we have for 1000. This is for multiples of 1000. First we have empty string. Then for 1 we have 1000. Then we have for 2 million. Then we have for 3 billion. Okay. Once we have understood how to solve this problem for 1 digit, 2 digit, and 3 digit, then we'll apply this 1000 to solve this problem. This is going to be super simple. Let's see. Let's say we're given this number 1, 2, 3, and this is our pseudocode. First we have I equals to 0. This I will points to the value of this 1000 array, or the list we store in this variable thousands. So here 0 initially points to the empty string. Then we'll increase I to 1, then it will points to 1000. Then we'll increase for the next 3 to 2 for million. Then for the next 3 digit to the billion. Now let's see how we can solve this problem. So first step is while loop, while num is not equals to 0. Then here we're going to call this helper method with the last 3 digit. Each time we'll call with the last 3 digit. For first call the last 3 digit, we'll find the base value for 3 digits, or for 1 digit, 2 digit, or 3 digit. Then we'll add the empty string. For the last 3 digits, we have empty string. We don't have 1000. Okay. Then we have the empty string words, and we have to concatenate that. And then we will just extract the last 3 digits, and we'll increment I to the next. For the next 3 integer, it will point to 1000. For the next, it will point to million. For the next 3 integer, it will point to billion by this I variable. Okay. This helper method takes one parameter n as input. Inside here, we're checking if n equals to 0, then we'll return empty string. If the given number is 0, then we will return 0 immediately. We can do that using if statement. If num equals to 0, we'll return just the text 0. And that's our base case. Or you could say that's our ace case. And that will handle in our code. Here we're just showing you the algorithm. Okay, this is n equals to 0. Here if n equals to 0, we'll return empty string. If n is less than 20, then we'll return the value from this box less than 20 at the corresponding position. And if n is less than 100, then we'll return the multiples of 10 by dividing n by 10. Then we'll call this helper method with the last digits. And here we have concatenated the empty string or the empty space. Else we will call less than 20, and here we will return the value from this less than 20 box by dividing the given number by 100, and then we'll add that to 100, and then we'll call with the last 2 digits. And we'll see how it actually works. This is for less than 20, this is for less than 100, and this is for less than 1000. So in this helper function, we're handling for our base cases when you have 1 digit, 2 digit, or 3 digits. And here our goal is to find out the value of last 3 digits, or the last 2 digit, or the last 1 digits. So the goal here is that we want to find out the last 3 digit, or last 2 digit, or last 1 digits. If we have 3 digit from the right, then we have to find out the value of last 3 digit. If we have 2 digit only, then we have to find out the value of last 2 digit. If we have only 1 digit, then we have to find out the value of last 1 digit. And that's what we are doing using this helper function recursively. Now let's see how it works for num equals to 1 to 3. If we have num equals to 1 to 3, then we see num is not equals to 0, and I is points to the empty string to our thousands. So here I is maps to this empty string, to this thousands box. And here we see num is not equals to 0, and then here we're going to call this helper method with the last 3 digits. So here we'll get the last 3 digit 1, 2, 3. In this helper method, we'll find out the value for the last 3 digits. Let's see how. Initially, we'll call this helper method with 1 to 3, and we see this is less than 1000. So it will goes to this else statement, and first we'll divide 1 to 3 by 100. We'll get 1 from this box less than 20. We'll return 1. So 1 plus 100 plus, and here we're extracting the last 2 digits from 1 to 3, something like this. Then we see 23 is less than 100. We're calling this recursively, okay? And then we're getting the value from this table tens by dividing this number 23 by 10. So we get 2, we'll return here 10, then empty string, then we'll call with the last digit 3, something like this. Then we see 3 is less than 20, so we'll just return 3 from this less than 20 box. And then we'll call with 0. This is for our base case. Here we don't need the last helper call, so we will just ignore it. So finally we'll just return 123, and we'll add that to this words, and this is this string 123 plus the empty string. So we'll add that to this word. Then the words equals to 123. So for this given input, we have to return 123. Now let's check another example. If we're given num equals to 1, 2, 3, 4, first we'll call this helper with 2, 3, 4. So we can get that by using this modulus operator. Then we'll call helper with 2, 3, 4. Then we have 200 plus helper 34 with the last 3 digits. And here we get 200 from this return statement, from this else statement. Then we'll call with this, and we get here 30 from tens using this statement. Then we're calling with helper 4, and it will just return 4 from this less than 20 box, and we don't need this helper 0. So here we'll return 234 to this helper function call, and then we'll add the first, this is our empty string, so I equals to 0 initially. So we'll add 234 plus empty string plus the words. What is empty string as well? So what equals to, we have 234. So for this input 1 2 3 4, we have the output 234. So we haven't solved this problem completely. We are left with the left one digits. So here we have divided the number with 1000. So we have extracted the number 223. So we have num equals to only 1. So num is not 0 and I is now pointing to 1000. Now we'll call this helper with 1. If we call this helper with 1, we'll just return 1. And if we return here 1 from this else if statement, in this case I is pointing to 1000, so 1000 plus the word, so 1234. So our words will be represented something like this, 1234. And then we're going to divide 1 by 1000, so num becomes 0, I points to the next, I points to million. Now in this case we see that num becomes 0, so num is not equals to 0. This condition evaluated false, so we're done. We'll just return whatever value we have at this word variable. So we have solved this problem for num equals to 1 2 3 4. Now let's take another example. For example, if we have 1 2 3 4 5 6, first let's find out the value for last 3 digits. We'll call with the last 3 digit this helper method, something like this. Then it will return 400 plus, it will call again with 5 6. Again it will call, this method will return 50 from this tens box by this statement. Then it will call with recursively with 6. Then it will return 6 from this less than 20. And then here we're calling helper 0. We don't need this since we're just returning from this less than 20. And we'll return 456 and we'll add that to our words. So we have these words. Initially I is pointing to this empty string. So this word plus empty string plus word already was empty string. So what equals to 456. Then we have extracted the last 3 digit 456. Then we have 1 to 3. So 1 to 3 is not 0. So now I is pointing to thousands. Now we have to find out the value for the next 3 digit from the right. Let's see how. We'll recursively call this helper method. Now num is 1 to 3. So 1 to 3 modulus 1000 equals to 123. So for 123 we can find out this value something like this. We don't have this helper 0 here. So we call this method helper with 123. It will return 100 plus helper 23, then 120 plus helper 3, then it will return 120, then 3. Okay, so we'll add that to these words. Helper will return 123 plus, here we have thousands, plus the words. So 123,456. So we get this string. So we get 123,456. And then we'll divide 123 by 1000, so the entire number will be 0. And then in the next iteration, while loop will be evaluated false. So we're done. We'll just return whatever value we have at this variable. That is 123,456. If we're given num equals to 1 2 3 4 5 6, we have to return 123,456. Hope you've understood how we can solve this problem. First, we have to find out the value of last 3, that is 456. Then we have to find out the value for the next 3 digits from the right, and we will append 1000 for that words for the value of 123. If we have 3 digits on the left of 123, then we'll add million to the words of that value. Now let's see how. So we have solved this problem already when we have 1 2 3 4 5 6. So we can discard this part. We have here 125. If we call this helper with 125 recursively, then I will point to million. So here I will point to million, and this helper 125 will return 125, and we will add 125, then million plus the word. So the word will be 125,123,456. So if we're given this number, we have to return these words. We'll divide 125 by 1000, number will be evaluated 0. So while loop will stop, and we'll just return this word, 125,123,556. This is how we can solve this problem. So we have solved this problem when you have 1, 2, 5, 1, 2, 3, 4, 5, 6. So let's discard this part. We already have that. And for first 3, I will point here. For the next 3, 1 to 3, I will point to the 2000. For 1 to 5, I will point to million. And then for 6, I will point to billion. And here, we'll call this helper with 6. In this case, we have only 6 here. It will just return 6. Then we'll append whatever value we have at current index of I. So here we have billion. So we'll add 6 billion, then whatever value we have at this word. So 6,125,123,456. So our words will be represented something like this. And then we'll divide 6 by 1000, then number will be evaluated 0, and we're done. This while loop stop, and we're done. We'll return the words. This is how we can solve this problem, and this is the concept to solve this problem. First, we have to find out the value of last 3, 455. Then we will add empty string. Then for the next 3, this is for 1000, 123,000. Then for next 3 for million. Then for the rest on the left for billion. Okay, if you are given a huge number, we can solve this problem using this concept. Hope you have understood how we can solve this problem. If you have an issue understanding this video explanation, let us know. This helper method recursively calls at most 3 times. So 3 is a constant. We're always just given to this helper method. So for the worst case, we will call this helper method with 3 digits, and that will take at most 3 steps. So 3 is a constant. We can say this helper method works in constant time and in constant space complexity. Time complexity of this solution is big of log n, and this is not a 2 base log, this is 1000 base log. Okay, and the space complexity is, we can consider big of 1. That means it works in constant space complexity. We have to use a less than 20, tens, and 1000. These are always just fixed, so we can consider constant space complexity. So we can say this solution works in constant space complexity, excluding the words that we're returning. Okay, hope you have understood this video explanation. If you have any question, if you have an issue understanding this video explanation, let us know. Thanks for watching. I'll see you in the next video.